Hello folks, this is video number 47 in support of the 3D Experience CATIA Generative Shape Design application playlist in YouTube. I'd like to continue discussing the parallel curve icon, which is part 2, where the support is a surface which has a curvature. When I did this thing in video 46, namely part 1, the surface was a flat plate, no curvature, okay? Because it was easy to explain things in that context. And now we're going to more or less repeat everything where the support is a general surface. But of course, I will not go through the details as extensively as I did in part 1. So when you're in generative shape design, there is a wireframe tab and there's a pull-up menu, which is parallel curves. And when you click on it, this dialog box opens up and it has several options, many options. And I did go through these in 46, but we'll see how much of it can be repeated here. Now, it is important to understand what does it mean to create a parallel curve on a surface. So suppose you have a surface like that and you have a curve on it, and we take a point. So what I'm going to do, this is the way the construction works. I'm going to find the normal to this curve, normal to the curve, which means normal to the tangent to the curve, obviously, at this point, a plane like that. Now, that normal to the curve plane intersects the surface on a curve, which I've denoted here by this blue curve. Okay, so this blue curve that you see here is the intersection of the surface with the normal plane to the curve. Now, when I say I'm generating a parallel curve where the distance d is the Euclidean distance, means that find a point on that intersection curve, on this blue curve, whose distance to that original point on the curve is d. When I say that this d is the geodesic distance, means that find the point, red point, on that blue curve such that the distance along this intersection curve, which means the distance measured as the distance as measured by the surface walking on this blue curve is d. Now, needless to say, you change the point, everything will change. You still get that red point, but don't expect to get something that's parallel to this thing. It just doesn't make sense. The word parallel, the only way you can intuitively justify that is that if that surface was a plane, and if this curve was actually a line, then parallel makes sense. But it applies to general situation as described to you right here. Okay. What I'm following, there is a CATIA V5 version of these tutorials by the YouTubers down here, and where this, for example, this topic among other ones that are discussed, and then there is also this one down here. The last 3 or 4 minutes of this bottom reference talks about the issue of smoothing and 3D smoothing on of this parallel curves, which I'm not going to discuss, but it would be helpful if you went to the last 3-4 minutes of this video that you see here. Okay, let's go ahead and do that. We're going to go to 3D Experience. I'm going to make a surface. And the surface is going to be a simple extruded one, but by no means that restricts anything that we're doing. So here I have a surface, or not a surface, a spline, and I'm going to extrude it. Okay, so make it 500. Okay, so I have a surface here. Okay, and then I want to make a curve. I want to make a curve on this surface. How do I do that? First, I'm going to make a curve up there, and then I'm going to project it. So let me make a plane offset from this, and let's say I go to 100, right there. On that plane, I will sketch any curve. For example, it can be a line, or it can be an arc. It really doesn't matter, or it can be a spline. So let me, for example, make it a spline, like so. Okay, right? Exit. Now this curve is not on the surface, but I can project it into the surface. So let's we have done this thing in earlier videos. So we go to wireframe and project, and I project that curve on this surface. Let me cancel that. Project, this thing opens up. For example, this curve on that surface, and you can do it either normal or along direction. It really makes no difference. Here, I'll make it along, for example, direction, I don't know, Z. That has no bearing. Notice that a curve has been projected down here. Now, I don't need this. I'm going to hide this. I don't need any of these planes. I'm going to hide them. Any of these planes I don't need. And I'm going to create, by the way, a point here. You might say, why do you need the point? Just bear with me for a few minutes on that surface. Doesn't matter where. Say right there. Okay, good. All right. Well, let me hide these guys. This is the sketch that I drew initially. Hide. Okay, and there's a sketch up there that I used for extruding purposes. I'm going to hide. Now, let me change the color of this projection right there. I'm going to change the color of that so we can see it better. Graphics, I'm going to make this thing say red. Okay, good, good. Now, we go to the parallel curve. Look, that's what it's asking, just like tutorial 46. A curve, which is down here, the projection one. Support, which is no longer a flat plane, is the surface. Now, notice that right now it says the distance is 0, so I'm going to make it 20. Let's see how it looks like. So this is what happened. So in this sense, it created a curve that is calling parallel to that curve. Okay? Parallel in this sense. Doesn't mean literally the translation, the shape of them are the same also. Doesn't mean that. Okay? Because you might get the impression that parallel means something that has been translated. That is not what this thing means. The definition is like this. Now, the other thing is that you go back here. Notice that, let me double click on this. In fact, there is two ways of doing this thing. The distance can be measured Euclidean or geodesic. Now, when you do that, these things will change. Let's change this thing to maybe 30, maybe more dramatic. Okay, all right. Yep. Now, let's go back here. Let's go back here. These icons are pretty much exactly the same in the sense that, let me move this thing the other way. In the sense that you can flip the direction. Right now, it's on this side. You flip the direction, it goes on the other side. Goes on the other side. All of these were discussed in video 46. You can do symmetric on both sides. Double click. So, double click on parallel. Let me not make it symmetric. You can extend it right there. See that? Until it hit the boundary. Right there. Linearly. Extend it linearly so that it hit the boundary. Let's go back here. It's not extended. And there is also the law here. Sorry, let me do something else first. Notice that you can also make that curve go through a point. So instead of giving a distance, I can select this and go and select that point that I created. Notice that as soon as I do that, this distance goes away and it goes through that point. Okay? Now, my curve, my surface here is very well behaved. If you had something that had a big bump on it, okay, it becomes obvious that these are not really parallel in the sense that you expect, not in that sense. Okay. Now, there is a couple of things that I wanted to do that here. Double click on this. Let me not make it through a point. Clear this and give it that same 30 millimeter. Let's go here. And notice that you can also do repeat. So if I say repeat, okay, 3 of them, all right, and it says that I'm running into problem. That's okay. So let's do it. Let's flip it the other way around. Let me Control Z. Yep. Repeat in the other direction. Okay. Let's see if 3 works. Well, kind of, not quite. Let me make this thing Control Z. Let me go there. Make it 2 instead. Or maybe I make this thing 20 and then let's use 3. Yeah. So we're going to make the distance Control Z. Let me try making 10. Repeat. Say okay. Two instances. There we are. I mean, if you put unreasonable number, at some point it's going to run into a problem, but you can see that this thing works. And even here, Control Z, double click. If I flip the direction, repeat, say okay, again 2, it's going to run into a problem. Okay, so the moral of the story is that you got to be careful with these numbers that you put in there because you may not be able to get what you're looking for. Go back here, Control Z, flip the direction, repeat. As a matter of fact, let me make these things. Yeah, that's fine. Say okay, and I'm going to make it 3 now. Did I flip the direction? I'm not sure. Control Z. Go back here, flip the direction, repeat, 3. Yeah. So one of these numbers it doesn't like, so it could be that the offset is, let me cancel that, Control Z. Let me change that thing to 10 instead. All right, and then double click, repeat, 10 millimeter, okay, 3 instances. Yeah, you gotta be careful. All right, so I think I've discussed everything that was intended. However, I mentioned to you that there is this smoothing and things like that that needs to be, one has to get more information about it. Unfortunately, it's not coming from the manual or the help, but the last few minutes of this video will give you some insight as to what those things are for. All right, folks, and have fun.